In this video, we're gonna see how we can install Tensorflow with GPU support on Ubuntu 22.04 TLS operating system. The version of Ubuntu we're using is very fresh installation. It just finished a few minutes before the installation. During the installation period, the installer discovered that I have the NVIDIA GeForce RTX 3080 graphic card installed, and automatically it installed the drivers for it, which is great. It also installed this NVIDIA settings utility. It was installed automatically. Now we have to do three main things. We have to install CUDA, the CUDA drivers. We have to also install the cuDNN libraries, which are used from the machine learning libraries, and also we have to install Tensorflow. These three things: CUDA, cuDNN, and Tensorflow. Let's take them one by one. The NVIDIA SMI, which again it was installed automatically during the installation process. I didn't install it manually. If you want to install it, it is a similar way like the one we're gonna see now, but since I started fresh, the NVIDIA driver is already installed there. Now, my very first thing is to install the compatible version of CUDA version, which is this. So if I go to Google, I just search for install CUDA version 11. As you can see, it takes me to the NVIDIA website, which has all these drivers, and it is, has very detailed instructions, but sometimes it's a little bit fuzzy and sometimes it's a little bit out of date, and this is what makes it a little bit complicated. This is why one of the reasons why people prefer to install Tensorflow from Docker or from Anaconda, because or even use Google Laboratory, because it hides this, because of the small inaccuracies in this side that make it a little bit difficult to install. For me, it took me a few hours to understand how to install it properly. So now I already have an account. It is free. I'm gonna log into it. Okay. It asks me to verify my account. I'm gonna go here. I already logged in once, so I'm gonna authenticate. Is this the one? Okay. Now I'm authenticated and ready to install my libraries. So you see that here it says CUDA Toolkit 11.7 update, 1 downloads. This is how this interface works. So from here you can select operating system, obviously Linux, architecture 86/64, distribution Ubuntu in my case, and version 22. And I have a choice of 3 different types of installer type. Obviously I'm going to select the deb, which is the easiest one. Immediately here we see the instructions. This is what I need to do now from the command line in order to install these drivers successfully. And this is what I'm gonna do one by one, very simple. I'm gonna take them one by one. I'm gonna pause the installation. Was running for a few minutes. One thing that happened to me twice, this is the second time because I have installed several times, is that at some point when it is installing the CUDA driver, the last line from here, it gives this error. Errors were encountered while processing this. Now, to fix this, I was able just to say fix broken, install. So this is gonna allow it to run to completion. I'm pausing the video again and we're gonna continue after it finishes. As we can see, after a few minutes, the installation of CUDA ran to completion. Where it is installed? It is installed by default in the USR local directory, where we have this CUDA 11.7. This is the home directory for the CUDA installation we're gonna be using. Now, our next step going forward is to install the cuDNN. This is the one that we need to install. There are many of them, meaning we have to find the applicable one. We have to be a little bit careful, and of course our friend in this situation is again the NVIDIA website, where even if we do a Google search and we say what is the version of cuDNN to install with CUDA 11.7, the one that we currently have. Immediately we see a whole bunch of results, and here we can see a very detailed analysis of the drivers that are applicable for our case, and also can see a detailed explanation of which driver we should use. So the one that we are supposed to use is cuDNN 8.5. So we're looking here we try to find it. So this is where we can download the driver for cuDNN. Let me keep this in a document so we can later share this. Okay, so download. I agree to the terms. Remind you that I'm already logged in here. So here I have two choices for CUDA 11 and 10. Obviously, we're gonna use the 11. And when I click this, as you can see here, I have an array of selections. So I'm gonna pick, since I'm working with 22, I'm gonna pick the installer for the Debian, this one here. Great. Now the objective is going to be to install this deb. Okay, the installer was downloaded. Let's verify this. This is the one that we're going to try to install now. From the same page where we were before, you can go to this installation guide, which has very detailed information how to install the cuDNN. One thing here, there are some mistakes, some deceiving information that we're gonna see how to go around here. First thing is that let's identify the section that we care about, which is installing in Ubuntu or in Debian. Just a second. And here this is the 232 section, Debian local installation. These are the steps we're going to follow, with some changes that we're gonna see now. Okay. First of all, you see that these cryptic numbers here, XXX and OS, these are what is matching the file name as it was downloaded, meaning XXX in this case is going to be 5096, nothing else, and the OS is going to be the Ubuntu 22.04. So first thing, since we have the AMD 64 deb, we're gonna install this. here dpkg. Okay. We see here that it tells us the public key does not appear to be installed. To install the key, run this command. All right. This is what they try to tell us here in the step 3. What I'm doing, I'm taking this as it is from here to avoid typos and things like this, and I'm just running it from there. That's it. Let's update our repo. Great. Now step 5, 6, and 7 are a little bit tricky, because they tell us to use to install the lib cuDNN 8 equal blah blah blah. If you try to execute it as it is, you're gonna see that it's gonna fail. You see, it tells us lib cuDNN was not found. All right. So this is what we need to fix now. And how we're gonna fix it? Let's remove this. So once I removed the the version numbers, as we can see, it goes forward. Okay, let's continue now with step number 6, which is pretty much similar to it. The only thing is installing the dev version, which is this. Okay, and now let's install some code samples just in case we're gonna use them. And I suggest you experiment with it, because with the C++ API. For now, let's just install it. Who knows if you're gonna use it or not. That's it. Now, if we go to our directory, user local, we can see that all the code that we care about exists in the CUDA 11.7 directory. What we are missing now is to advertise this location and make it available to the TensorFlow level, so it's gonna know how to access the CUDA libraries. How are we gonna do this? What I'm doing, I'm just changing my bashrc file, and what I'm doing, I'm adding in the bottom of it I'm adding to the ld underscore library library path here. We're gonna add the directory the local CUDA 11.7, this directory here, CUDA that's 11.7, yes, and inside here there is this lib64. This is what we need. These are the libraries and the DLLs that are going to be used from TensorFlow. So what we need here is the lib64. And of course, put it like this. First in the line. Now we see, for some reason, we also need to do the same thing, but for this CUDA directory. I'm not exactly sure why this is needed, but it is. Meaning I tried it before and it needs this as well. So here we continue with the LD library path, and now we are adding the same lib64, but we are adding it from CUDA. I think this is correct. Okay, this is our bashrc. Excellent. Now let's source it, or start a new terminal. It doesn't really matter. Now we are ready to install TensorFlow. Let me update the repos. Okay. Let me see. I do not have pip. Let me install it. Great. Okay, pip is there, and now I'm just doing pip install. That's it. If everything works, this should be fine. Okay. To prove that our installation is correct, let's bring up a Python session, import TensorFlow. There is a function in TensorFlow that is checking exactly this. I don't remember it by heart. Let's see it. TensorFlow, check if you are using, I searched for it before. Is another one. Yeah, let's try this, but I think this is deprecated. But it's gonna work. Let's see. True. Great. You see, is enabled. Yes, this is the other method to check for available GPU devices. Yeah, this means that it found the device. So now we can use our local TensorFlow and put it in Jupyter or our test directly for our machine without having the need to, to run it from Docker or from Anaconda, and things that greatly complicate, in my opinion, the development. This is a plain vanilla installation, which is what I was looking for, and I think you should give it a try if you wanna test using it like this. And the other thing is that I haven't tried to install it in a virtual machine. I think it's gonna be a little bit more complicated. Maybe this is gonna be the topic of another video. Thank you so much, and let me know if you have any questions. Bye.